Hello everyone. In this video, we are going to discuss about matrices. Before going through the exercises of matrices, we must have to know the basic, the preliminary things related to matrix. Now let us first see what matrix actually is. What is said here? Some basic illustrations is a heading here. Matrix is a rectangular arrangement of numbers and functions. So basically a matrix is a rectangular arrangement, means it looks like a rectangle but not exactly a rectangle, because all the properties of rectangle it is not carrying. In very simple words, these numbers and functions can be arranged into forms of rows and columns. Rows and columns. So if we go through this definition, everything is not clear from this part. So let us relate this particular concept with a real life example. Now, just look at the second part. Everyone please look at the second part. Considering a real life example. We all know that for any statistical survey, some tabular informations may be required. Such format of a table is this. Suppose in a particular survey, some informations we have to collect, and we have to collect these informations in the format of this table. Say in the first column, name of the persons will be there. In the second column, age of the persons will be considered, while in the third column the gender of the persons will be specified. Now suppose the first person, it is mentioned here as Rahul, he is of age 16 years and he is a male, while Garima is of age 15 years and she is a female. So this kind of informations are tabular informations, means all these informations can be arranged in the form of a table. Now in the above table, we get rows and columns. It is very clear that in the above table, means whatever table is framed here, in this table, the vertical arrangements will be considered as columns, and the horizontal arrangements, like this part, will be considered as row. Okay. So in this tabular form, we are getting rows and columns. Now, matrices are nothing but the type of table only where we get rows and columns involving only numbers. There is a difference between actually what I want to say is matrix can be considered as a kind of table. But there lies a difference between table and matrix. Where lies the point of difference? In case of matrices, in case of matrix, we shall be getting only numbers, and wherever necessary there can be functions. But in case of table, there may be names of persons, then can be age, it can be gender, which are not particularly numbers. Suppose it's gender, it cannot be number. Name of the person cannot be number. So what conclusion can we draw out here? All matrices can be considered to be table, but all tables cannot be matrices. So there lies a difference, and this can be considered as a real life example of matrices. Now, when it could be considered as a matrix, another example we consider here. Suppose in the first column we are having number of books. In the second column we are having number of pens. In the third column we are having number of notebooks. Suppose in the first column we are having number of books. In the second column we have number of pens. In the third column number of notebooks. So these all are vertical arrangements, that means columns. Okay. So here each horizontal arrangement, suppose each horizontal arrangement is assigned after the name of a person A, B and C. Suppose A is having 9 books, 3 pens and 7 notebooks. Similarly, B is having 8 books, 6 pens and 3 notebooks. Similarly, C is having 2 books, then 3 pens and 4 notebooks. So, if you forget these headings A, B, C, then books, pens and notebooks, there will be left behind only these numbers. Only this section of numbers will be left behind. So this above table can be considered to be a matrix because it contains only numbers categorized under books, pens and notebooks. While writing the matrix form of this above table, we do not have to draw these lines. Remember one thing, when suppose these headings, if we remove books, pens, notebooks, then for A, then B, then C. If these headings A, B, C and books, pens and notebooks are removed, in that case only these numbers will be left behind. So these numbers, while writing there is a particular specific way of writing a matrix. While writing a matrix, we should be sure that these lines, it is drawn in between this tabular form, this should not be drawn. Only these numbers should be written 9, 3, then 7, then 8, 6, 3, then after 2, 3, 4. And this should be, the whole thing should be closed under this box. So actually a matrix can be represented in this way. Just now whatever I told you, that is what is written here. Within this box we are getting all these numbers. There is another way of writing matrix. This is this. But remember one thing, this curly brackets is not applicable for matrices because this is applicable only for sets. So coming to the next part, when we have, suppose this is a matrix 9, 7, 6, 3, 2, 8, 2, 4, 5. Suppose this is the matrix. All numbers are written here. Okay, all numbers are written here. Now, what the specific name is given for these numbers? These numbers can be replaced by functions also, like trigonometric functions or algebraic functions or anything like that. So each of these parts, each of these terms is known to be elements or entries of the matrix. Elements or entries of the matrix. So as I told you, each number of these functions contained in the matrix can be considered as its element. For example, sin x, cos x minus sin x. This is another form of matrix involving only the trigonometric functions. You already know these functions are known as trigonometric functions. So that is what is written here. Each of these functions are called as trigonometric functions, and each of these terms like sin x, cos x minus sin x, each of these terms will be known as elements or entries of the matrix. Again, these matrices, suppose in a matrix we are having, please look at this figure. In the highlighted part, the pink highlighted part means this horizontal arrangement represents a row, while the vertical arrangement, the yellow colored highlighted part, is known as column. So in this matrix there are two rows, first row, then second row, and these three are columns, 3 columns. So we are having 2 rows and 3 columns in this matrix. What is the order of a matrix? Let us see. Suppose we have a matrix with the terms x, y, z, then a, b, c. Very clearly there are 2 rows, row 1, row 2, r1, r2, and there are 3 columns, c1, c2, then c3. So here in this case, how to determine order of the matrix? Remember one thing, that order of the matrix is denoted by number of rows into number of columns. So in this particular example, as we are having two rows, that is why 2 will come first, followed by into sign, then after followed by the number of columns. So this is the order of the matrix which we have considered just now. So what is said here, if a matrix has m number of rows and n number of columns, then the matrix is said to have order m cross n, m is into n. Then the matrix is said to have order m into n. It is read as m by n. So always remember, look at this highlighted part. Always remember one thing, while writing the order of a matrix, the number of rows should always come first, followed by the number of columns. That means, suppose if a matrix has m number of rows and n number of columns, then order will be m by n. That means number of rows should always come first, followed by this into sign, then after followed by number of columns. We consider another example where we have two rows, row 1, this is row 1, then this is row 2, and three columns we have. So here in this case, number of rows are 2, then number of columns is 3. So order of the matrix will be what? Number of rows into number of columns, that is 2 by 3. So certain things you have to notice here. First note, look at this first note. Matrices are named always using the capital letters of English alphabet. Like this is a matrix X, Y, A, B. What order it will be having? 2 rows and 2 columns. So order of this matrix is 2 by 2. This is named as capital A. Capital A is a letter of English alphabet. So matrices are always named after the capital letters of English alphabet. Remember this. Then the second note, this is an important one. So let us consider a matrix which has m number of rows and n number of columns, and it is represented in the way, in what way it is written here. Let us look at this part properly. Let us consider a matrix is having m rows and n columns. So what is the value of m? That we don't know, and what is the value of n? That is also not clear to us. So randomly we assume that m is a big value and n is also a big value. So in what way the matrix A will be arranged in that case? So the element present in the first row and first column will be represented as A11. The element present in the second column and first row, that means first row and second column, will of course be represented as A12. In that way it will go on. Similarly, the element present in the second row but first column will be represented as A21. Then element lying in the second row, second column will be represented as A22. In this way it will be going on. But what is the specific thing that we have to notice is element lying in the second row and first column. You can notice one thing, that the element is A but its position is second row. Second row, that means 2 is coming first, followed by 1. 1 is what? Position of the column. Second row, first column. This first column is replaced by 1 here. Okay, so 2, 1. Similarly, the element lying in the second row, second column. So first, this 2 represents the position of the row. This 2 represents the position of the column. So in that way we have to arrange. So let us have a look at this table. So that is what is written here. Suppose this is second row. These are the second row elements. Second row first column means A21. Second row second column is A22. Second row third column means A23. Second row jth column. J is any number lying in between first element of this row and last element of the same row. Then the last element is A to N. N is the position of column, and 2 is the position of row. The same thing goes on up to the last. This is the position AMN. AMN is what? AMN is position of this element in the mth row and nth column. So just now, the type of matrix representation whatever we discussed is a very large type of matrix representation, and it consumes a lot of time. Therefore, to minimize this problem, actually it will be taking a long period of time to complete writing the entire matrix, and it will be taking space also. So to getting rid of this kind of problem, there is a specific, actually the mathematicians developed a specific way to represent a matrix containing large number of rows and columns. So the entire thing, whatever is shown just now, can be reduced to the form A is equal to Aij. Aij with m number of rows and n number of columns. So what is the specific thing found here? I represents the position of the row and J represents the position of the column. I represents the position of the row and J represents the position of the column. So randomly we have chosen amongst this list of elements, randomly we have chosen any element Aij which can assume any value depending on position of the row and column. And remember one thing, that this value of I and j should be having some kind of restriction. Value of I should always be lying between 1 and m. Similarly, value of j should always be lying in between 1 and n. Why so? Because I you can be found, but actually number of rows, position of the rows can only be within 1 and m, because number of rows of the matrix is m. Therefore, the first value I represents the position of the row. Therefore, it should lie only in between 1 and m. Similarly, for j, again the number of columns of the matrix is n, and value of j can attain values in between 1 and n, including both the values, means j is greater than or equal to 1 and less than or equal to n. So this should be taken care. So what is said here? Let us look at this writing part. So the number of entries are considered as an arbitrary element Aij which belongs to the ith row and jth column of the matrix A. In very simple words, when I is equal to 1 and j is equal to 1, then we refer to the element A11 when the position of the row is 1 and position of the column is also 1. When the position of the row is also 1 and position of column is also 1, in that case we can understand that we can refer to the element A11. So when the value of I is equal to 1 and j is also equal to 1, we can refer to the element A11. Why so? Because value of I, when value of I is equal to 1, it will refer to the position of the row, and when j is equal to 1, this will also refer to the position of the column. In other words, we mean to say that the element is lying in the first row and first column. In other words, we mean to say that the element is lying in R1 and C1. R1 stands for row 1, C1 stands for column 1. Similarly, when I is equal to 2 and j is equal to 3, that means when the position of the row is 2, that means it is R2. When position of the row is 2 and position of the column is position of the column is 3, that means C3. The element is lying in second row and third column. Second row and third column. So how the element will be looking like? Position will be looking like this: A, 2, 3. So that is the way of determining the position of an element in the matrix. And the position of this element A23 can be shown in the matrix in this way. Please look at the highlighted part. The element A23 belongs to second row and it is belonging to third column also. So the position of the element will be this. Position of the element will be this. It is lying in the second row and third column. So the above representation shows the element A23 lying in the second row and third column. So that's all about the informations before starting the first exercise of matrix. Regarding the different types of matrices, another video will be prepared. So in the next video, we shall start with the exercise of matrices, first exercise of matrix. Thank you.